This is SpaceTime Series 21, Episode 9, coming up on SpaceTime. A new model linking high-energy cosmic rays, neutrinos and gamma rays to supermassive black holes. A black hole discovered hiding deep inside a globular cluster. And a new study which could help predict volcanic eruptions. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
One of the biggest mysteries in astroparticle physics has been the origins of ultra-high-energy cosmic rays, very high-energy neutrinos, and high-energy gamma rays. Now, a new theoretical model reveals that they all could be shot out into space after cosmic rays are accelerated by powerful jets from supermassive black holes and travel through galactic clusters. The findings, reported in the journal Nature Physics, helps explain the origins of all three types of cosmic messenger particles simultaneously, becoming the first astrophysical model of its kind based on detailed numerical computations. The study's lead author, Assistant Professor Geita Moraes from Penn State University, developed the model with colleagues from the University of Maryland. The fact that the measured intensities of very high-energy neutrinos, ultra-high-energy cosmic rays, and high-energy gamma rays are roughly comparable got the authors wondering if these extremely energetic particles have some sort of a connection. The new model suggests that the very high-energy neutrinos and the high-energy gamma rays are both produced through particle collisions as daughter particles of cosmic rays. That means they can inherit the comparable energy budget of their parent particles. Consequently, their similar energetics wouldn't just be a coincidence. Ultra-high-energy cosmic rays are the most energetic particles in the universe, each of them carrying far more energy than could be produced by science's most powerful particle accelerators. Neutrinos are mysterious, ghostly elemental particles that interact only very weakly with the rest of matter. In fact, there are billions of them passing through you unnoticed right now. And very high-energy neutrinos, with over 1 million mega-electron volts, have been detected by the IceCube Neutrino Observatory in Antarctica. Of course, gamma rays can have the highest known electromagnetic energy. Those with energies more than 1 billion times higher than a photon of visible light have been observed both by the Earth-orbiting Fermi Gamma-Ray Space Telescope as well as ground-based observatories. Now, according to the new model, powerful quasar-like jets generated by supermassive black holes can accelerate cosmic ray particles out of the radio lobes often found at the end of the jets. The authors then calculated the cosmic ray propagation and interaction inside groups and clusters of galaxies, and how they can be influenced by surrounding magnetic fields and other environmental properties. The authors then simulated the cosmic ray propagation and interaction in intergalactic magnetic fields and other environmental factors between the cosmic ray's source and the Earth. Active galactic nuclei produced by feeding supermassive black holes were always the leading suspects in this half-century-old mystery. At the same time, the very high-energy neutrino spectrum above 100 million mega-electron volts can be explained by particle collisions between cosmic rays and gas in the interstellar and intergalactic medium. Also, the associated gamma-ray emissions coming from galactic clusters and intergalactic space matches what cannot be explained by high-energy gamma rays emitted directly by active galactic nuclei. However, the new model can't explain everything. For example, there's still mystery surrounding IceCube neutrino data in the 10 million mega-electron volt range. So, while we may be seeing the start of a golden age for ultra-high-energy particle astrophysics, there's still an awful long way to go. I'm Stuart Gary. This is SpaceTime. Now, while on the subject of black holes, astronomers have for the first time discovered an inactive black hole hiding silently in the heart of a globular cluster. The invisible black hole is more than 4 times the mass of our Sun and is being orbited by a star almost as big as the Sun. Astronomers got their first hints of this secretive black hole when they observed the star moving strangely in a globular cluster known as NGC 3201, located some 16,300 light-years away in the southern constellation Vela the Sails. Globular clusters are huge ancient spheres containing tens of thousands of tightly packed stars, which were originally all born together in the same molecular gas and dust cloud. They're among the oldest known stellar systems in the universe, dating back to near the beginning of galaxy growth and evolution more than 12 billion years ago. Globular clusters are usually found orbiting around the outskirts of galaxies. In fact, more than 150 are currently known to belong to the Milky Way. The star that they were looking at was being flung backwards and forwards at speeds of several 100,000 kilometres per hour, with the same orbit repeating every 167 Earth days. Now, this strange acting star is a main sequence turn-off star, meaning it's at the end of the main sequence phase of its life. Having exhausted its primary core hydrogen fuel supply, it's now on the way to becoming a red giant. The star's unusual movements indicate it's orbiting something very small, apparently invisible, and yet extremely massive, the perfect description for a stellar mass black hole. From its observed properties, the star was determined to be about 0.8 times the mass of the Sun, and the star's movement due to the black hole's enormous gravitational well allowed astronomers to calculate the mass of the black hole, finding it to be around 4.36 times the mass of the Sun. That makes this the first ever discovery of an inactive stellar mass black hole in a globular cluster, and the first found by directly detecting its gravitational pull. Stellar mass black holes are usually formed when massive stars die, collapsing under their own gravity and exploding as powerful supernovae, sometimes called hypernovae. Left behind is a black hole with most of the mass of the former star. This can range from a non-rotational mass of as little as 2.16 times that of our Sun to several tens of solar masses. The discovery, reported in the monthly notices of the Royal Astronomical Society, impacts on science's understanding of the formation of star clusters, black holes, and the origins of gravitational wave events. The discovery was made using the European Southern Observatory's MUSE instrument on the Very Large Telescope, or VLT, in Chile. MUSE is undertaking a large survey of 25 globular clusters around the Milky Way, providing astronomers with a spectra of between 600 to 27,000 stars in each cluster. The study includes analyses of the radial velocity of individual stars, that is, the speed at which they're moving away from and towards the Earth along the line of sight of the observer. With radial velocity measurements known, the orbits of stars can be determined, as well as the properties of any massive objects they may be orbiting. The study's lead author, Benjamin Geisers from Germany's Georg August University, says the star's intriguing behaviour meant it had to be orbiting something invisible, very small, and extremely dense. That could only mean a black hole. The relationship between black holes and globular clusters is an important but mysterious one. Because of their large masses and great ages, globular clusters are thought to have produced huge numbers of stellar mass black holes. These would have been created as the more massive stars within the cluster exploded and collapsed over the cluster's long history. In the absence of continuous star formation, as is the case for globular clusters, stellar mass black holes eventually become the most massive objects present. Generally, stellar mass black holes in globular clusters should be about 4 times as massive as the surrounding low-mass stars. Recent theories have concluded that black holes form a dense nucleus within the cluster, which then becomes detached from the rest of the globular material. Movements at the centre of the cluster are then thought to eject the majority of black holes, meaning only a few would survive after billions of years. I'm Stuart Gary. You're listening to SpaceTime. Scientists say they may have found a link between volcanic activity and tidal cycles. Researchers say that just before a surprise eruption of New Zealand's Ruapehu volcano in 2007, seismic tremors near its crater became tightly correlated with twice-monthly changes in the strength of tidal forces. The findings, published in the journal Scientific Reports, suggest signals associated with tidal cycles could potentially provide advanced warnings of some volcanic eruptions. Data from this volcano, spanning about 12 years, shows a correlation between the amplitude of seismic tremors and tidal cycles developed in the 3 months before the eruption. The study's lead author, Tassilo Girona from NASA's Jet Propulsion Laboratory in Pasadena, California, says what that suggests is that tides could provide a probe for telling scientists whether or not a volcano has entered a critical state. Earth's tides rise and fall daily due to the gravitational pull of the moon as Earth rotates. During full and new moons, the lunar gravitational pull lines up with that of the Sun, which makes the daily tide bulges a little larger during those moon phases. On the other hand, during the first and third quarter moons, the daily tidal bulge is a bit smaller. While we normally think of these tides in terms of rising and falling waters, these gravitational stresses also affect the planet's solid crust. The question of whether gravitational stresses influence volcanic activity is long-standing in Earth sciences. A lot of research has been focused on whether or not tidal forces can trigger eruptions, and there's no definitive evidence whatsoever that they do. So our authors wanted to take a different angle by looking instead at whether there's some sort of detectable signal associated with tidal forces that says something about a volcano's criticality. The Raupeau volcano was chosen because its activity has been closely monitored by scientists for years. You see, the mountain's a popular tourist attraction and home to 2 ski resorts, so officials want to be aware of any warning signs that it might erupt. And that monitoring's provided a long, continuous data set for researchers to study. The authors focused on seismic sensors located near the volcano's crater. These sensors pick up volcanic tremor, a low-level seismic rumble that provides a persistent signal of activity within a volcanic system. The authors combed through 12 years of seismic data, looking for any period when seismic activity could have been correlated with lunar cycles. They found that for most of those 12 years there was no correlation between tremor and lunar cycles. Except, that is, for a few months before a steam-driven eruption on September the 25th, 2007, when a really strong correlation emerged. During those 3 months, the amplitude of the tremor rose and fell ever so slightly in lockstep with a fortnightly tidal cycle. And while the fluctuations in the seismic amplitude were subtle, the strength of the correlation to the tidal cycle wasn't. In fact, this correlation was as strong as 5 sigma. That means the probability of the pattern arising purely by chance was only about 1 in 3.5 million. To understand how tidal forces could have been affecting the volcano during these 3 months, the authors used a model of seismic tremor that they had developed previously. Volcanoes like this one have a vertical conduit through which lava rises and a solid rock plug at the top acting like a cork. Gases released from the magma form a pocket between the rocky plug and the magma pool below. And that gas pocket can resonate against the plug, creating seismic tremor. When the pressure of the gas pocket reaches a critical level, a level at which a steam eruption is possible, the differing stresses associated with changing tidal forces are enough to change the amplitude of tremor. And that's what the authors think was happening in 2007. When the pressure in the system became critical, it became sensitive to the tides. And the authors were able to show that the signal was detectable. And that's important because none of the other indicators geologists typically use to anticipate eruptions raised any warning flags in 2007. The authors now want to collect more data from other eruptions and other volcanoes to see if the same tidal signal shows up elsewhere. Only then can they start thinking about using it as a potential means of predicting future eruptions of this kind. Interestingly, the findings come just a week after another study, this one by the US Geological Survey, found no correlation between tidal forces and increases in major earthquake activity. Those findings, reported in the journal Seismological Research Letters, compared dates and lunar phases to 204 earthquakes of magnitude 8 or greater, finding no evidence that the rates of these giant earthquakes are in any way affected by the position of the Earth relative to either the Moon or the Sun. You're listening to SpaceTime. I'm Stuart Gary. And time now to turn our eyes to the skies and check out the celestial sphere for February on Skywatch. February, of course, is the second month of the year in both the Julian and Gregorian calendars. It's also the shortest month of the year, as it's the only one to have less than 30 days. The month has 28 days in common years and 29 days in leap years, with a 29th day known as a leap day. The additional days needed every fourth year to keep the calendar year synchronised to the astronomical year. Because seasons and astronomical events don't repeat in convenient whole numbers, calendars that have the same number of days each year will drift over time with respect to the event that the year is supposed to track. By inserting an additional day into the year, that drift can be corrected. These extra days always occur in years that are multiples of 4, with the exception of years divisible by 100 but not by 400. As well as inserting leap days into leap years, the length of a day is also occasionally changed by inserting leap seconds into Coordinated Universal Time, or UTC, more often referred to as GMT, or Greenwich Mean Time. These leap seconds are needed because of variability in Earth's rotational speed. Unlike leap days, leap seconds are not introduced on a regular schedule, since the variability in the length of a day is not entirely predictable. Throughout most of February, sky watchers in the Southern Hemisphere may be lucky enough to catch sight of the occasional meteor associated with the Alpha and Beta Centaurids meteor showers. Now, as their names suggest, they appear to radiate out from the direction of the constellation Centaurus as 2 separate streams. But don't expect a big show, as they rarely produce more than 1 or 2 meteors per hour. Still, if you're interested, they will be peaking on February the 8th. To best see them, look towards the east, just a few hours before dawn. Looking north and high in the sky this time of year is the famous constellation of Orion the Hunter. In Greek mythology, Orion is said to have boasted that he could kill all the animals, so the earth goddess Gaia sent a scorpion to kill him and save the animals. Scorpio, the Scorpius, stung Orion in the shoulder, but the healer Ophiuchus saved Orion and crushed the scorpion. Both Orion and the scorpion were then placed in the heavens to play out the story each year, with Scorpius rising in the east as the defeated Orion sets in the west. Then when Ophiuchus crushes Scorpius, forcing him to set in the west, a revived Orion can again rise in the east. Interestingly, variations to this same story appear in other cultures, including ancient Egypt, where Orion is known as Osiris, the god of the underworld and of regeneration. To those of us in the southern hemisphere, of course, Orion appears upside down, with the sword in his belt pointing upwards. The scorpion's sting is represented by the red supergiant Betelgeuse in Orion's shoulder or armpit. It's a massive star. In fact, were Betelgeuse at the centre of our solar system, its surface would extend out past the main asteroid belt, wholly engulfing the orbits of Mercury, Venus, Earth and Mars. Calculations of its mass range from slightly under 10 to a little over 20 times that of the Sun. Betelgeuse is a variable star located approximately 643 light-years away and is expected to erupt as a supernova any day now. Of course, in astronomical terms, any day now could mean tomorrow, or it could mean in a few million years' time. Diagonally opposite Betelgeuse is the blue supergiant star Rigel, one of Orion's knees. Rigel is some 863 light-years away. It has some 23 times the mass and an incredible 279,000 times the luminosity of the Sun. Rigel is actually part of a triple or possibly even quadruple star system with 3 or 4 small companion stars. The primary star, Rigel A, has exhausted its core hydrogen and is now swollen out to between 79 and 115 times the Sun's radius. It pulsates quasi-periodically and is classified as an Alpha Cygni variable star. Rigel B is itself a spectroscopic binary system consisting of 2 main sequence spectral type B blue-white stars, estimated to have 2.9 and 3.9 times the mass of the Sun respectively. Rigel B also appears to have a very close visual companion known as Rigel C of almost identical appearance. One of the best known features on Orion's sword is Messier or M42, the great nebula in Orion. Located some 1,344 light-years away, it's the closest massive star-forming region to the Earth, some 24 light-years across and containing about 2,000 times the mass of the Sun. By studying the Orion Nebula, astronomers have learnt much about the process of how stars and planetary systems are formed from collapsing clouds of molecular gas and dust. Astronomers have been able to directly observe protoplanetary disks, failed stars called brown dwarfs, intense and turbulent motions of gas, and the photoionizing effects of massive nearby stars in the nebula. To the west of Orion's belt is a distinctive V-shaped group of stars which represent the head of Taurus the bull, who in Greek mythology was actually the god Zeus, who changed his form into a bull so it could attract the princess Europa and carry her off to Crete. The V is actually part of a large open star cluster known as the Pleiades. One of Taurus's eyes is a giant spectrotype K orange star called Aldebaran, or the Follower, which is located about 65 light-years away and is about 1.5 times the mass of the Sun. Aldebaran has also evolved off the main sequence, having exhausted its core hydrogen supply. The collapse of the centre of the star into a degenerate helium core has ignited a shell of hydrogen outside the core. The Aldebaran system is thought to contain a number of Jupiter-sized planets. Aldebaran follows the Pleiades, or Seven Sisters, a spectacular open star cluster to the northwest of the V. Located in the constellation Taurus, the Pleiades are one of the nearest and youngest open star clusters, located just 443 light-years away. In the Aboriginal culture of the Great Victoria Desert region near Aldea in outback South Australia, Orion is seen as a young male hunter who chases but never catches the Pleiades, who are a group of 7 young women. In Orion's right hand is a club filled with magic fire, represented by the red giant star Betelgeuse. However, the Pleiades' older sister, represented by the Hyades star cluster, taunts Orion, standing in front of him. She defensively lifts her foot, which is the star Aldebaran, and is also full of fire magic. This causes Orion great humiliation, putting out his fire and allowing the Seven Sisters to escape. One of the interesting facts about this ancient story is that it accurately describes the variability of Betelgeuse, which brightens and fades over a period of about 400 days. This Aboriginal Pleiades Seven Sisters story is remarkably similar to mythology and legends found in many other cultures around the world, cultures which haven't had any contact with each other for tens of thousands of years, yet somehow the story has remained. The seven brightest stars in the Pleiades can be seen with the unaided eye, hence the name Seven Sisters. But this spectacular open star cluster actually consists of well over 100 stars. Now, following Orion's belt to the east brings us to Sirius, one of the nearest and brightest stars in the sky. Located just 8.7 light-years away, Sirius is a binary star system with a spectral type A white star orbited by a white dwarf. Sirius is the brightest star in the constellation Canis Major, the Great Dog. In Greek mythology, Sirius was the dog star and the canine companion of Orion the Hunter. To the ancient Egyptians, Sirius was the god Anubis, the lord of the underworld. Anubis had the head of a dog and invented embalming and the funeral rites and guided one through the underworld to judgment, where he attended the scales during the weighing of the heart to determine one's fate in the afterlife. Later, Anubis was replaced in Egyptian mythology by Osiris as lord of the underworld. Interestingly, Sirius also represented the goddess Isis in ancient Egypt, and Egyptians initially based their calendar on the star's yearly motion across the sky. Let's turn to the south, and looking high in the southern sky in February, we see Canopus, a white supergiant located 313 light-years away and the second brightest star in the night sky after Sirius. In Greek mythology, Canopus was the helmsman or navigator of the Greek king Menelaus. It's the brightest star in the constellation Carina and represents the keel of the boat Argos, used by Jason and the Argonauts in their quest for the Golden Fleece. Located nearby are the vessel's sails, represented by the constellation Vela, and the roof of the boat's rear cabin known as the poop deck, which is represented by the constellation Puppis. Now, also in the southern skies this time of year are the large and small Magellanic clouds, which are two dwarf galaxies close to our own galaxy, the Milky Way. The Magellanic clouds were known to the Polynesians and Maori, serving as important navigation markers. They were named for Portuguese navigator Ferdinand Magellan, who was the first European to sight them during what was the first navigation of the Earth between 1519 and 1522. Magellan never completed the journey, being killed in the Philippines during the Battle of Mactan. Right now, the Large Magellanic Cloud is located almost directly overhead. In reality, it's 163,000 light-years away. Although it looks like an irregular dwarf galaxy, astronomers classify it as a disrupted barred spiral galaxy. It's about 14,000 light-years in diameter and contains about 10 billion times the mass of our Sun. The Small Magellanic Cloud is slightly lower and to the west. It's located about 200,000 light-years away. It's classified as an irregular dwarf galaxy, about 7,000 light-years wide, with about 7 million times the mass of the Sun. Astronomers speculate that it was, like its larger companion, once a barred spiral galaxy, but became disrupted by the gravitational perturbations of the Milky Way. Jonathan L. is the editor of Australian Sky and Telescope magazine, and he joins us now for the rest of our tour of the February night skies.
Now, as far as the planets go, Stuart, it's a bit of a mixed bag this month, actually. Mercury, the innermost planet, it's around the other side of the Sun during this month, so, of course, we can't see it. It's out of view. Venus, too, the next planet out from the Sun, it's out of view. It's also been around the other side of the Sun. Theoretically, if you have a very flat horizon, no trees or houses or hills or anything in the way, if you're out in the middle of the desert, then technically you might just see Venus pop its head over the western horizon at sunset or just after sunset during February, but for everyone else, just forget it, you're not going to see it. But come March, it will be coming up again, the western sky, after the sun has set. It'll become the evening star, as they call it in inverted commas. For the other planets, you're going to need to be an early riser. Jupiter and Mars are both rising in the east around about 1 a.m. at the beginning of February and a bit earlier as the month goes on. Mars will appear to be not too far away from a star that looks much the same colour and brightness. This is the star Antares, which is the brightest star in the constellation Scorpius. And Antares means the rival of Mars. The name is very similar. Well, Ares, Antares it is, and Ares is another name for Mars. And finally, the other planet that we can see with the naked eye, Saturn, it's also a very early riser, so you've got to be either up late or up early. It's coming up over the eastern horizon about 3:30 a.m. These are all Australian times, by the way, Eastern Australian times. 3:30 a.m. at the beginning of February. Now, Saturn, just like the other planets, just looks like a brightish star. to the naked eye. But if you know someone who's got a telescope, or obviously if you've got one yourself, turn it on to Saturn, have a look at the rings and everything. Really, really quite spectacular, Stuart.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And this is Space Time. I'm Stuart Gary. And time now to take a brief look at some of the other stories making news in science this week with a science report. Paleoanthropologists from the Tel Aviv University have confirmed that a jawbone and teeth discovered in an Israeli cave represents the oldest human fossil found outside Africa. 3 separate and independent dating techniques were used to confirm the age of the fossils, which were first discovered in the Mislia cave on the western slopes of Mount Carmel in 2002. The remains effectively push back the date that humans first left Africa by between 40 and 50,000 years. So, instead of leaving Africa between 90,000 and 120,000 years ago, the confirmation means humans were already on the move between 177,000 and 194,000 years ago, far earlier than previously estimated. The fossils exhibit teeth that are in the upper size range for what's seen in modern humans, but otherwise show clear patterns and features of Homo sapiens. As well as the human remains, scientists also discovered some early stone tools, which had previously also been linked to the emergence of Homo sapiens in the region. Scientists have discovered that tiny crystals as small as grains of salt, forming dip in volcanoes, could be used to help determine the possible timing of volcanic eruptions. The findings, reported in the journal Nature Communications, could be good news for the almost 1 in 10 people around the world who live within 100 kilometres of an active volcano. While not being the holy grail for predicting volcanic eruptions, the research means a significant step forward in understanding the process that leads to eruption. The crystals grow at depths of around 30 kilometres and continue to crystallise and change in composition as they move upwards in erupting magma. Using a new laser technique, the authors, including University of Queensland volcanologist Dr. Teresa Ubaid, examined crystals in magma deposits from previous eruptions of Mount Etna, Europe's most active volcano. They were able to determine when new magma entered Etna's volcanic system and how long it took to reach the surface in an eruption. The authors found that in 90% of eruptions, a fresh eruption will occur within 2 weeks of new magma entering the Etna system. While the actual timing of these events will be unique to each volcano, the research, combined with changes in earthquake activity, temperature, gas release, and deformations in the surrounding terrain, can all be used to help volcanologists narrow down the timing of a likely eruption. A new study has found a link between levels of vitamin D in blood and respiratory health. The findings, reported in the Journal of Respirology, are based on a study of over 5,000 adults aged 45 to 69. Scientists found low levels of vitamin D were associated with increases in asthma, bronchitis, wheeze and chest tightness, while high levels were associated with healthy lungs. Scientists have discovered that just like people, most female cats are right-handed. The findings, reported in the journal Animal Behaviour, indicate that while there was no overall population preference like the human preference for right-handedness, there was a gender preference. Researchers studied 24 male and 20 female house cats. The animals were monitored in their own homes, so the information could be gathered as they went about their usual daily tasks. The cats' owners collected spontaneous data on whether the cats used their left or right paws as they went downstairs or over objects, and whether they slept mostly on the left or right side of their bodies. A forced test was also carried out, in which the cats had to reach for food inside a 3-tiered feeding tower. 73% of cats showed a poor preference when reaching for food, 70% showed a preference when stepping down, and 66% when stepping over objects. Researchers found the preference for right or left-handedness was consistent for the majority of tasks, both spontaneous and forced. In all cases, male cats showed a significant preference for using their left paw, while female cats were more inclined to use their right. However, when sleeping, cats don't appear to have a side preference. The findings could help cat owners understand how their pets deal with stress. You see, researchers had previously discovered that dogs who are left-handed have more pessimistic outlooks than right-handed dogs. From a pet owner's perspective, it might be useful to know if an animal is left or right limb dominant, as it may help them gauge how vulnerable that individual is to stressful situations. Believe it or not, it's been just over 6 years now since Apple first launched Siri. Since then, Amazon's come out with its Alexa personal voice assistant, and Google have been pushing their Google Home Assistant. They're all designed to allow you to turn on devices like lights or the air conditioning, change TV channels or play music, all done by simple voice commands. They'll even tell you what's making news, what tomorrow's weather will be like, or where the nearest restaurant is. All you need do is ask. They each have their own advantages and disadvantages. With the details of the very latest in personal voice assistants, we're joined by Alex Zaharov-Reutt from IT Wire.
Well, this week it's all about Amazon Alexa, the digital assistant that's already been rolled out quite widely in the States, is coming to Australia with a lot of companies announcing that they have launched skills for Alexa.
And what will Alexa do? Is this just another version of Siri?
It is another version of Siri or the Google Assistant, but Amazon has sort of rolled its assistant out before Google Assistant really took on and before Siri has had its HomePod speaker made available to purchase. Some of the skills that have been announced, you can ask your bank, have I been paid? You can ask it whether or not you've got any credit left. You can tell different electronic components in your home to switch on or switch off. But even things like you can ask your shower to, hey, start the shower and put it to 30 degrees. You can do more things by voice with more devices. It's been something that's part of science fiction for years.
Yeah, I mean,
but it's now
how often have you seen an episode of Star Trek in which they simply say, computer, turn on the screen or what have you?
Yeah, I mean, they take it for granted in those particular shows. We also heard this week that Amazon Alexa, the app, is getting voice support on Android, and also soon it's coming to select Windows PCs.
Will that then replace Cortana?
Look, Microsoft announced late last year that Cortana and Alexa would work together. So we now have digital assistants that are talking to other digital assistants. Pretty soon we're going to have one digital assistant aggregator. I mean, otherwise you have to go through the house asking Siri to do one thing, Google to do another, and Alexa to do something else. And that's going to start driving people nuts. I was at the LG stand at CES and they were showing the Google Assistant as part of that television, and you can speak into the remote and get it to change the color setting. And you can get it to change channels. And even though the TV is blaring with audio, it can still pick up on what you're saying. And that's another thing that Amazon is saying, that it's got these beam-forming microphones. And even if something is playing, it can still hear for that keyword Alexa. The other problem, of course, though, is that when you talk about beam-forming microphones in your house, well, it brings up a very 1984 scenario.
That must be frightening then.
Well, it is and it isn't. I mean, you have to be able to trust that the provider that's providing that service to you isn't just listening to everything that you're saying.
That happens now. You've seen the movie Snowden.
Yeah, I saw that.
Haven't we already reached that stage where Big Brother already knows everything you're doing?
Yeah, so look, it's a big fight between whose system is going to be supreme, whose system is going to be the safest.
That's Alex Zaharov-Reutt from IT Wire. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. If you want more Space Time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary. At Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.